I'm Agostino Bruzzone. I'm very glad to be here to give such presentation. Unfortunately, I'm not able to be with you, but I'm with you in spirit. In any case, I am in the other side of the planet in this moment. Therefore, this presentation is done jointly by me and by Dr. Alberto De Paoli, that is my assistant, and I will give you such quick and brief view about the potential of a new discipline that is called strategic engineering. So now if technology will support me, I will switch to the screen. And let me see if we can see the presentation. Very good. So the topic that I will present is strategic engineering, that, as I anticipate, is a new discipline, and we will take a look about it could be used in energy sector with special attention to supply chain for energy, and that in a changing world that is even more stressing this aspect. Let's take a look at the introduction. Okay, energy for sure will represent a very challenging sector. There are many issues. We're sure that you are familiar with most of them, but just let me go through choosing flower by flower, where for sure there is some basic aspect. The point is the world population is growing, developing countries are requesting more and more energy. So there is a growing demand. At the same point, we are concerned about environmental impact in terms of pollution, in terms of greenhouse gases. We have issue about sustainability, not only in terms of environmental impact, but in terms of social equilibrium, economy, energy, water, food, in terms of scarce resource that should be balanced based on the demand that is changing. The demand have to deal with that. And currently, we are seeing speculation and conflict arising, and there's a situation that is not easy to be inverted nowadays. Energy saving for sure is a way. There are required efficiency actions. At the same time, sometimes this efficiency action goes against the greenhouse gases reduction, because some of the power saving in the past was based on additional combustion or reused aspect, like in iron and steel. We have an opportunity for refurbishing of existing facility. We are continuing exploring and extracting new traditional source. We are constructing new plant. We have huge investment in construction in renewable energy that now represent a significant percentage, but it's not easy to go forward. We have issue about construction new plant. We have even aspect related to new opportunity that are behind the corner, but this corner is not so near, like fusion, like molten salt reactor, new way to produce, or let's say an old way that we are rediscovering for producing nuclear energy that is improved a lot based on current technology in robotics, etc., and obviously renewable. So that means that we need the technologies. As you can see, we need the resource. We need to be smart. And we need intelligence, not just artificial intelligence, but we need to be intelligent in adapting that, and maybe artificial intelligence can help us. And strategic engineering could be an answer to this aspect in such a contrasting world where the demand in developed country as well in the world is changing, and there is a huge request for energy in terms of industry, commercial, residential, transportation that share, not exactly, but I believe industry one of the major consumer and is fundamental for the development. All these aspects that we need to match have to deal with some framework that we can call VUCA. VUCA stands for volatility, uncertainty, complexity, ambiguity. So what it means that the world where we have to deal with the needs of energy and the solution to produce such energy and the way to use this energy in a smart way is characterized by some characteristics that make it even more hard to face. One for sure is uncertainty. if we look to this current situation, there are been big change along the last 10 years that probably most of people was not expecting, or maybe they was a little bit naive is not expecting, but it is not trivial. The current crisis between Europe and Russia and Western country and Eastern country is reducing access from West to some kind of source that forces us to energy transition much faster than expected. At the same time, in addition to uncertainty of what will happen, we have volatility because what we know now, the system change quite quickly. The system complex because there are many factors that interact in not an easy way. Sometimes there are ambiguities, not very clear what is some position over there. To face this challenge, we need to get a vision, to be able to understand, we should be able to clarify the complexity, and we should be agile in order to adapt to ambiguity. So let me say, in this sense, strategic engineering could help a lot. Strategic engineering deal with the capability to combine data analytics, model simulation, and artificial intelligence in a way, in closed loop, let me say, with the real data, the big data that we collect to support decision. But what is important to understand in strategic engineering is that strategy is not just planning. Strategy is to bien direct. One of the major strategists of the history, General Jomini, Swiss general of Napoleon, was to say that strategy c'est l'art de bien diriger. So it means that you should be able to direct, you should be able to define your own objective, tune the objective, readapt your plan, and even get the final result and succeed. Now, when we talk about energy, you can address that in many ways. So that could be to identify what are the major sources, how to balance them, how to make it resilient. For sure, one criticality in energy is to be resilient. That if we like this, the sector of energy, this is a huge challenge. I will address just a specific aspect that is related to supply chain management, devoted to support the service of existing plant. But this is a tiny slice where you can do a lot of things and get a lot of saving and improvement, but you can even extend to other aspects. First of all, we need to have clear in our mind as not only what is strategy, but even what is a complex system. Complex system usually is an entity that is a composition of many interconnected elements that are usually reacting in self-adapting and generating emergent behavior that could be not so intuitive to realize. I make you an example that is quite trivial but interesting. Last year, due to the shortage of water, and you know, one of the most rich countries in Europe in terms of water is Switzerland, but Switzerland feed two of the major rivers that go across Central Europe. But due to the lack of water, the channel that are connecting port like Rotterdam, Antwerp, Hamburg to the internal part of Europe was in shortage of water. And this is what generated. It generated the fact that the barge bringing gas in Swiss was not able to arrive with the frequency expected. It is generated a shortage in terms of energy availability. Obviously, it could compensate by cost sometime, but it's impacting. And you never think about the fact that missing water, think the problem could be drinking, the problem could be obviously agriculture much more than drinking because agriculture uses 70% of the water. But in this case, the consequence of lack of rain was a lack of gas for energy. So they are strongly interconnected. It's not so easy to go through. So how we deal with that? We need strategy. And we need strategos, as the term was used once upon the time to define the people that was the admiral and the general that was managing the fleet and the armies of the old city-state from Greece. And Socrates was used to say, what is a strategos? He was answering, and he said, stratego is somebody that have an art. The art to know a little bit better than others what is going and what will happen. And if you think about it, it's fundamental for strategy to have a vision, to know what to achieve, to understand what is going. It was exactly the kind of point that we need in order to face VUCA. We need to have a vision. We need to understand the system. We had to clarify complexity and be able to take decisions. Now, strategic engineering don't create strategos, but create engineers or provide to engineers techniques that could allow to support strategies. Another very important quote that I would like to mention, it came out from Sun Tzu, the Chinese strategist, that was used to say that the general that win the battle make many calculations in his temple, here the battle is fought, while the general who lose make few calculations. Now, 2,500 years ago, maybe the calculation was done based on the abacus, Chinese abacus, but nowadays this can be done by computer simulation, artificial intelligence, data analytics. So we have to think about that. The basic idea of strategic engineering is to collect data. Nowadays we have many, many more data. I remember in the end of the 80s, at least by myself, in the end of the 80s, we had the capability to collect data from plants, power plant that was located in Asia, Central Asia. Per day, we get the equivalent hours. That's good, one number. Was arriving by, there was not even email, was arriving by fax. So we was keeping track how the consumption of hour was going, to plan the maintenance of gas turbine, and even to check how the steam turbine was performing. Nowadays, we get thousands of data per second. So it's intuitive that we can do much more because we can measure vibration and identify if there is some emergent symptom of a failure. These data are not clean. So we need data analytics and probably artificial intelligence to understand this data, to fuse different data, to filter, and to extract information. And that's very good. Could allow us to what is happening. But to what is happening is not a no, because what is happening don't tell us what we have to do. We just say what is happening. But we have probably alternative choice. And to compare the impact of different choice, for instance, we have to stop, we have to wait to make an inspection. We have soon an inspection expected. So we anticipate a little bit the inspection, we look inside, or we wait more. What is the right choice? Analyzing data don't tell us, at least not when up to the moment that this happened. That could be too late. So we need models. Model feed by this data, and mostly by the information that we extract from this data, cleared, certified. So by modeling and simulation, we can look forward the impact of alternative decision, evaluating risk, taking the right decision, or the most promising, based on our attitude to the risk. But obviously, no plan works as expected. No? So probably when we take this decision, then things will go, we hope, pretty good, but maybe not exactly the same. And so the idea is to get in a closed loop the real data, to compare with our expectation, to use machine learning to reduce the error by correcting the parameter of the algorithm, as well as the factor that tune the simulation in order to generate a virtuous cycle. Currently, we created Strategos around 5 years ago, with the initiative Strategic Engineering born around 6 years ago, 7 years ago in MIT. And currently, we are pretty successful. We have a PhD program jointly with Spain, France, Hungary, and extending. We have a master program that is ongoing, that in 3 years turned to be the largest Master of Science in Genoa University. That's pretty large university. And one of the most successful, the first one in Italy. We have many companies, as you can see, major one, Thales, Leonardo, Hitachi, Ansaldo. We have many consulting companies like Accenture, Bearing Point, RINA. We have many high-tech, and we have many agencies and institutions like Sovereign Order of Malta, Water Academy working with United Nations, and NATO excellence centers in modern simulation and so on. So it's a great opportunity. If you are interested, we'll be glad to keep in touch with you. For sure, we have to address new challenge and new threats, and even to combine, to create new tools that have this vision, because simulation is pretty new considered, but in reality exists for over 50 years, as well as artificial intelligence. We have all seen the movie where artificial intelligence was used to break Enigma and was one of the factors to win the war, the Second World War. And even data analytics, I say that data analytics dates back to time of Romans, when data analytics were used to decide how much to order. But nowadays, we have so many data around that we can do much more, just because this platform is available. Let me talk quickly about energy. In energy, obviously, we have many aspects, even the traditional power plant, no? We had a huge necessity to maintain the plant, to maintain efficiency. This is not only for the old traditional fossil plant, but even for photovoltaic or for solar, we need to clear the mirror, or for aeolic, we need to identify a way to guarantee it. And all the new plants have such aspect. And one of the most profitable activity in service, in energy, is the service. And often service is some way captive, because if I develop a energy infrastructure, probably I am strongly favored in providing the service. Normally, service is much more profitable than construction of the energy infrastructure. And WTs could allow to improve the customer satisfaction, and we needed to provide a supply chain management to guarantee that we have all what we need for doing the service. That means spare parts, people, proper moment, respecting the technical commercial need. So these constraints, in fact, are related. Some of our users want to concentrate the maintenance and stop maybe power generation in a period. Someone wants to keep it distributed homogeneously among different sites. Sometimes on the sites you cannot work concurrently. Sometimes on the site you need to have space that it cannot allow you to mount, for instance, to turbine. You have contract, you have period of the year that could be not convenient for economic region or for contractual region, etc., etc., etc. So obviously there are many aspects in this sense, and nowadays you have big potential in terms of developing preventive maintenance and combining with your predictive maintenance. So obviously one of the core aspects is to guarantee availability. That is the issue, not so easy, because availability often relate to the capability to provide energy additionally, not only when it's expected, but even in other moments that could turn profitable. It's very important, even the reliability of your energy infrastructure, obviously. You have to manage properly warehousing. That is not just logistics, but is even thinking about how to design your energy infrastructure to be optimized for service. So for instance, sometimes you generate so many configurations that are mostly equivalent, but duplicate items in your warehouse. Obviously, if we talk about turbine that are a significant part, and combined cycles and gas turbine, there's a lot of inspection, minor, major revision that needed to be properly addressed to optimize cost, to optimize availability, and to properly plan this activity. There are many constraints, as I said. Many constraints. It's not easy to combine all together. And there are a lot of expectations even. In this sense, you have to define the survey kits that are required by the power plant. You have to identify what is the inventory level that you need to keep for the critical component that could be kit, bearings, spare parts, but at the same time that could be strategic aspect like the blades. The blades obviously in turbine are critical. They are subjected to refurbishing, so it means that you can dismount and refurbish, and so you can remount on some other plant, but it requires some time. Each time that you can refurbish a layer, just a layer among several one, rotor or let me say stator layer, you save around $800,000, $1 million, and there are several layers. Obviously, at the end, after some refurbishment, you have to regenerate. But this means that the longer time frame of a contract, that could be 12 years, and maybe for a pool, for a set of plant, this could change by million and million of dollars the profitability of your activity. This is very critical. So if it is a look about the planning of the first fire and then the maintenance, minor and major inspection, you have to decide when you regenerate, when you buy. And this means that you have to even to define strategy about cannibalization of item. That could be even a strategy, but is not, should not turn to be a contingency. And all this kind of evaluation should rely on a smart planning, on a proper model that could allow you all the consequences, because in this case you have many consequences that go around the different combination. Simulation could be the basic for service as well as the support for artificial intelligence to investigate, identify the most promising solution. Over there, obviously, uncertainty is a major issue. We have the demand, we have the scrapping, we have how the single machine in a site, among a set of sites, operates, and to identify so what could be the proper time to make the inspection, when you are expected, even to plan if you can refurbish in time some layer or not. You have to analyze these factors and to identify how to rotate. For instance, the blade, just the blade, each layer, along 12 years, it means that you can save for a single layer some $1 million. And if you have several layers, that means $dozen million for machine, and maybe you have 12 machine, so you can understand that we talk about $100 million profitability. And but this is not just profitability, it's even allowing to reduce the risk of stop. That means penalty for you that provide the service, of losses of revenues for the seller. That means usually hundreds of $1,000 per day, or even million per day. And these alternatives need to be matching all together. So it's evident that we needed some tool to address all this together. I mentioned in this case is Lapis architecture that combines simulation, artificial intelligence, and data fusion to identify what are the most promising spectrum. And in addition, use even fuzzy logic in order to investigate and evaluate what is the quality of your plan, to provide you indication about how you can improve your own performance. So to identify the source, because in the term of artificial intelligence, very important to understand what are the promising from artificial intelligence, what are the motivation. Otherwise, it's turned to be in black box. It's very hard to follow indication by black box. You need something that could semi-explain. We talk about XAI, that means explainable artificial intelligence. Fuzzy logic can help it. Simulation can deal with stochastic to carry out risk analysis to evaluate alternative or different planning. Not only on the main, we talk about blade, but we have to talk about key strategic component that could be a rotor, or etc. That's a big deal with to decide if you want to include in the service an extra rotor. That means 1 million, maybe to prepare the blade ready to be mounted. So when you're on a mounted rotor, you have the other rotor that could be already mounted, shutting down by days the stoppage that is by an investment of $1 million, you have to analyze. And obviously VV&A is fundamental. That means verification, validation, and accreditation. And I feel this could provide you an understanding about what are the motivation for using this kind of system. In this case, we was using extensively the genetic algorithm to combine all different ideas, possible alternative in planning, to provide a proposal, even including the proposal by users, and then to test if they can work properly. So I feel this could provide you a good idea about the potential of these techniques. And if you have any question, I will be very glad to answer. Thank you very much.